So let me start sharing my screen and yeah, just give me a couple of minutes. Yeah, I think probably you can see that. My today's title is Overview of PV Modules Growth Beyond Traditional Applications. I would like to use a slide from Ariane. According to REN 21. So it is a very recently released global status report. According to this report in 2022, so that is the latest available data, modern renewable energy accounts for just 13.4% of the global total final energy consumption. So that means fossil fuels really take the lion's share, which is above 41 plus 31, so that is 77%. So electricity represents only 23% of this total energy consumption. It had a highest share of renewables, so which is 30% in 2022. And actually, this has increased from 23% of 2015 level. Unfortunately, you can't see that kind of information here. But in contrast, heat and transport sectors together, they account for 77% of the total final energy consumption. 46 percentage for heat and 31% for the transport. But they really lag in terms of uptake of the renewables, where heat only 10 close to 11% and 3.5% for the transport. So actually this is but this tells that with solar being the lowest cost and most versatile power generation source, solar has the potential to capture much of the electrification potential in all sectors. So just want to tell you that, what's the potential we have with solar and how much we can go further. And, think tank, so this is another slide from yet another slide from a third party. So this is from think tank Ember. Their recent electrification study shows in one of their graphs that how financially attractive is electrification of power demand for households. Households in US and UK, for example, they currently spend around a sixth of their income on energy related needs. And renewables can really help households to save money. So for example, by lowering the wholesale prices or through distributed generation, they can reduce the energy bills by hundreds of dollars per year in their energy bills. But there is also an indirect impact. So by cutting the spending on transport and heating fuels and reducing the equipment and maintenance cost, it has also a potential to save the households thousands of dollars annually. I think this is estimated to be around 3 to 5% of typical Western household income. But when we think of solar, the case for solar electrification, it is not just economics, it's also improving the quality of the life. And that too without affecting the consumer's experience, because whether the power is coming from solar or burning of the fossil fuel, the end consumer experience is the same. So, the benefits of solar is better quality of life. So for example, if you take EVs or heat pumps, which are way more better than their fossil fuel based alternatives. So actually these benefits are not really going unnoticed. So that is why we are seeing more and more solar applications. The needs of these applications range from simple tweak to a considerable upgrade. So just look at what can be, made solar suitable for different applications with material optimization. So this is a slide I took copied from one of earlier J Solar's presentation. I think Francisco in today's presentation is also going to show something, but I think it's really much more advanced. So I think you would not mind what I'm using here. So here it really gives already a very nice overview. What are the large scale of applications of PV and how can you reach those application requirements? So for example, if you are putting a panel on ocean or lake through FPV, floating PV, what you need is, it should have very high damp heat resistance, and it should be PID resistant. It must be able to withstand UV and all this. So for that, what you need is a highly weather resistant double glass layer coated glass, and then probably a better encapsulation. And then a waterproof, and then probably a polyurethane frame, and also sometimes you can have a edge sealant. So similarly, you have different applications like dust and sand. I think today's topic of Francisco is also dust, so he will cover more into detail. So today, by tweaking these bill of materials, we are able to, not we, but the industry or the solar manufacturers are able to offer quite different product portfolio that is absolutely suiting to the requirements of very specific applications. But then PV is also nicely shifting into different nomenclature. So BIPV is really one of early non-traditional applications, and now it can really replace every material or component in building. You name it, actually you have it. So if you are at any of the trade shows, it is very, it is not so easy to miss all this, colorful modules. You have roof tiles, you have even floor tiles. So that means you can even walk on them. There are some specific BOM modifications and where you can walk, and then these are floor tiles and they still produce power for you. And there are facades, and then there are carports, curtain walls, glass. I think we will hear more from Gain Solar. And I think the key for BIPV, when we talk to these vendors or the developers, I think the primary objective for BIPV here is to match the reliability and lifespan of building materials, and aesthetics actually plays a very important role. And of course, but anyway, so the suppliers are offering in different sizes, shapes, and I think the key is really to integrate PV nicely into the building. So this also brings one more kind of additional burden on the PV. So it not only has to meet the norms of the PV, but it also has to meet the norms of the building. And moving on to another interesting application. So I think Hamid will show in one of his slides even today. He also presented in our previous conference. So land is getting expensive. So, and very flat land or very solar suitable lands are really is becoming a distant dream. So, and land is getting expensive. So the dual use of the land is almost the tagline of every agrivoltaic promoter. Here, the land can be used for basically agriculture and also for solar. And now this is also emerging into several subfields. So you have different designs. You have like what you see here, vertical, then there are translucent, there is one absent string, and there are some trackers so that, they move according to the requirement of the, so I think here, again, they have to meet two ends, one, the crops and also the yield. So they have to strike the right balance. I think we are going to hear, as I said in the beginning, we have Huasan, who is going to speak a case for the vertical installations. And, agri-PV is really getting hot in Europe and India, again, for combining agriculture with PV production. And yeah, so flexible and lightweight is almost became a common product in our common development target for nearly every leading module maker. So if you are scrolling through any of the new product announcements, it's very tough to miss such an announcement. But this is not really an application, but this is a rather a design aspect, and yeah, so the applications are really are endless. So you can integrate these flexible modules in weight sensitive application, roofs. You can put it on the vehicles. I think day by day these applications. So as solar is getting flexible, it's getting more and more opportunities and finding more ways to be integrated into daily life. And the popular designs are frameless, using very thin or semi-flexible glass, or completely polymer glass. Sorry, polymer. There are really different varieties of wraps that are available in today. So I think the key point for the flexible PV, when we were talking to the key suppliers, is to match the mechanical stability over their conventional counterparts. And yeah, floating PV is, I think it's really emerging, and TaiyangNews has also published a dedicated report on floating PV. I think the one of the USP for floating is to be co-located with hydropower projects to use the power infrastructure of the existing these hydro generation plants. So, not yet probably in developing countries, but I think we all know we are reaching the limits for the grids, and the hydropower plants are typically seasonal. So that means for some part of the season where this capacity, so the grid capacity is idle or is not used to its optimum level, that can be very nicely compensated for floating PV, but it's actually not limiting there. So though in small quantities or maybe still in prototyping or pilot phase, floating PV is also reaching offshore. So again, here also, the main target is to use the grid infrastructure that was built for wind. So right now, several leading companies are offering floating PV panels. So that means you can get off-the-shelf products from some of the leading suppliers. Okay, I think vehicle PV, as I mentioned, it's really one of the budding technology. Yeah, a few years ago, Fraunhofer ISE has really displayed a very nice car roof made with PV. But I think current development is really focused towards the durability against the vibrations and heat, and probably sticking it onto the roof, especially when you have larger transport vehicles like trucks, where you have a higher surface area. I think this is really getting interesting. And then PV thermal is also an interesting concept where you can combine heat and electricity generation in one circuit. So I think the most important developments here are, split junction boxes, glycol-based heat exchangers, and combining and to be compatible with heat pumps. And a few companies are really trying to launch the products by end of this year. A few are already available. Yeah, I think balcony solar is really one of very nice examples of DIY solar. Of course, we all know garden lamps and very small applications, but I think balcony solar is a little bit more than that. It's a serious PV system. It has really components, but it is DIY, do it yourself nature. I think this is also getting very interesting, and it's giving a entry for urban market to get electrified with PV, especially apartments and all this kind of setups. Yeah, and interestingly, several big companies are also venturing into that, some companies are really serious that they are even implementing very advanced technologies like BC into balcony systems. So with this, I would like to end my presentation. Thank you very much for your attention. I will stop sharing my screen. Great. And if you have any questions, please put your questions here in the chat window. I will try to answer, but it's more or less you can find all this information in one of our recently launched report, which summarizes the products that were launched at recent solar shows.